In my previous video, I looked at the very basics, atoms, elements, mixtures, compounds, looking at the periodic table and what the groups and the periods mean, how elements look to gain or lose electrons in order to have their full outer shell, how the periodic table is mostly made up of metals and those metals are looking to lose electrons in order to get that full outer shell, whereas the non-metals are looking to gain electrons to have that full outer shell. And we talked about the exchange of electrons, which is ionic bonding between the metals and the non-metals. So now I want to look at balancing equations and state symbols and some other useful things for you to know. So let's take an example of lead nitrate and potassium iodide combining, reacting. So over here we have lead nitrate, potassium iodide. These are our reactants, and we end up with lead iodide and potassium nitrate. Now you might remember, and we will talk about it a little later, the reactivity series and how this reaction works, because potassium is more reactive than lead, and therefore the potassium will displace the lead from the lead nitrate and make potassium nitrate, leaving lead to combine with the iodine and make lead iodide. So let's look at the symbols then for this. So we have lead nitrate. Now, I remember some formulae and I can then use that to work out how things are going to react. So I remember, for example, nitric acid. And I know that hydrogen forms an H plus ion. Now that means that the NO3 has to be a single minus. And I know then that lead is going to have a 2 plus from its position in the table. It tends to form 2 plus ions, not always. And so I know I'm going to have PbNO3 twice. Now this AQ means an aqueous or solution in water. Likewise the AQ on the potassium iodide. So let's then bring in our equation for our products. So there's our chemical equation in words. Here we have our products. And we have potassium nitrate. Now I know potassium is in group 1 and it will form a single positive ion, and I know the NO3 from here is a single negative ion, and so I'll have potassium nitrate. And because lead is 2 plus and iodine is in group 7 and therefore wants to gain a single electron, then it has to be PbI2. And again, we have AQ and AQ. The other symbols we could have, well, we could have L for liquid, so not mixed with water. We could have G for gas. We could have S for solid. So here we have our symbol equation. Now we have to make sure this is balanced. We can't have any more or less lead or nitrate ions or potassium or iodide here than we have here. So if we go through, we've got one lead. Good so far. 2 nitrates, 1 nitrate. Now we've got a problem. 1 potassium, 1 potassium, 1 iodide, 2 iodides. Iodides over here. And we need to account for the 2 nitrates over here. So if we had a 2 there, we'd account for the 2 nitrates. If we had a 2 there, we'd have the 2 iodides we need and we'd have the 2 potassiums we now need because we put a 2 in there. So there we have our balanced equation. What we're doing is looking to make sure that whatever we have on this side by way of elements or ions, so we have lead ion, we have nitrate ion, we have potassium ion, we have iodide ion. These are all going to be over here. They're attached to different things, but they're still here. So we have to have the same number of potassiums, nitrates, leads and iodides over here as we have over here. And so we put our numbers in to balance our equation and we check and it's right.